I'd like to dive into the JSON format and how we can effectively utilize it within our Node.js applications. If you've dabbled in JavaScript for the browser, you're likely already acquainted with JSON. This is because quite often, when we send requests to web servers, the responses come back in JSON format. While understanding JSON is beneficial for front-end developers, it's absolutely crucial for back-end developers, particularly those working with Node.js. So, it's definitely worthwhile to quickly review the JSON format and explore how we can manipulate it in JavaScript, especially in the context of Node.js. To kick things off, let's remove our utils file since we won't be using it anymore. Now, let's start with something straightforward. We'll define a constant, which we'll call x, and initialize it with a value of 1. Next, we want to create a JSON string that captures the value of this constant. I'll name the constant for our JSON string, JSON string. To convert our numeric constant to JSON, we can utilize the built-in JSON class that's available in JavaScript. Inside this class, we find the stringify method, which allows us to seamlessly convert any JavaScript variable or object into a JSON string. We just need to pass the variable we wish to convert, as in this case, x. And there we go. Now we have the JSON representation of x stored in our JSON string constant. Let's log the value of this JSON string. When we run the program, we'll see the output as 1. While this isn't overly impressive, we might argue that it's simpler to simply print the value of x itself rather than its JSON string representation. However, we can use this method to represent every value in JavaScript as a JSON string. So let's look at another example. Instead of a numeric value, how about we try a string? I'll change the value of x from 1 to hello. When we run the program now, we can see that hello appears within quotes, which signifies its JSON representation. Again, this might seem trivial. Now let's switch gears and work with an object. After all, JSON stands for JavaScript Object Notation, so representing an object will give us a clearer picture. We'll rename the constant to object1 and assign it a few fields in key value pairs. I'll provide the object with a first name, a last name, and a date of birth. Instead of stringifying x, I'll stringify object1 instead. Running the updated program reveals the JSON representation of this object, which closely resembles the object we defined in our JavaScript code, but now it's represented as a string. One might argue it's easier to read the object as it's written in the code than in JSON format. Fortunately, we can enhance the readability of our JSON string by adding some white space. To accomplish this, we simply need to pass 2 additional parameters to stringify, the first being undefined, followed by the number of spaces we want for indentation. I'll opt for 2. When we run the program again, we'll notice that the same object is now formatted for better readability, with each key appearing on its own line and an indentation of 2 spaces. Next, let's explore how we can save the JSON representation of an object. This becomes particularly useful for persistence. If we aim to store data long-term, relying solely on memory, like using variables, isn't the best approach. Files offer a much more reliable solution for storing information persistently. So how do we save our JSON string to a file? Interestingly, it's quite similar to what we've done before with writing text files in Node.js. We start by requiring the fs module, and once we have that, we can simply use write_file_sync. For the first parameter to write_file_sync, we'll specify the path to the file. Let's call it myJSON. The second parameter will encompass the content we want to write to this file, which in this case is our JSON string. After running the program, we'll not only see the JSON output in the console, but we'll also have a new JSON file created. If we check the file's contents, we'll find it mirrors what we see in the terminal. Now let's take this a step further. Imagine we have default values that could change over time. This idea ties into persistence. We don't always want to start from scratch with default values. Instead, we'd like the object's content to evolve over time. The values we initially provide will serve as defaults unless the file already exists, which means we can have an updated representation. If the file exists, we'll read its content and pass that JSON string to retrieve the current values for the object. To do this, let's define a constant for the JSON file name. Next, we need to check if the JSON file exists. If it does, we have updated values that we want to apply to our object. When the program starts, we initialize this object with the default values, but if the file exists and contains updated information, we need to override those defaults accordingly. For this, we'll utilize JSON parse, which serves the opposite purpose of stringify. It transforms a JSON string back into a JavaScript object. We'll pass the read content of the JSON file as a parameter to parse. To read the content, we'll employ read file sync. This will provide us with the updated object values, assuming the program has been run previously and the file exists. We'll also use our constant for the file name when saving, ensuring we read from and write to the same file. Let's run the program now. We'll need to correct a small error by changing object1 from a constant to a variable, as it might need to update with the file's content. Upon rerunning the program, we see the same results, displaying the object's current values. Now, let's edit the content of the JSON file. For instance, if we change John to Steve for the first name, running the program again reveals that the output reflects not the default values, but those retrieved from the JSON file. This simple example illustrates how we can initialize an object with default values while allowing those values to be overwritten when updated content exists, all thanks to the JSON format.